Oh, wait, no.
You find all the hydrogens?
Find two, just two.
Oh.
Just two. Two's good.
Put the other papers back in it.
So,
Wait, Mr. Strauss, what should we use for us?
oh, I thought you grabbed the cards out of there.
Oh.
Aren't there spares in there?
Yeah.
And if you can't find two hydrogens, just write H on two cards. Now, hydrogen each has one electron. So take two different color Froot Loops. I'm taking one yellow and green. And the first thing you always do is you check to see if it is ionic or covalent. So the electronegativity of hydrogen is 2.20. The other hydrogen is 2.20. Take the difference. Comes out to be 0. Is that ionic or covalent? Covalent. So always do that first. Check to see if it's ionic or covalent. So it's covalent, which means you are going to be sharing. If you are sharing, then you follow the rules on Appendix F. Okay? If it was ionic, it just steals it and takes it. But we're not stealing here, Harry. We're sharing. So hydrogen is in group 1A. So according to our rules, hydrogen must finish with 2 electrons around it. So what they do is, instead of the electrons spending their time out there, they spend their time between each other. They share their electrons. And the way this would look, writing it Lewis-wise, is like this. You would write H. I like to draw circles around so that I know that there are 2 around that one and 2 around that one. That would be the Lewis dot structure for hydrogen. Now the official IUPAC way is to just use all dots and do that. I like to use different symbols there so that you guys can see where the electrons are coming from. So that's the Lewis dot structure there, Pat. Then how many pairs do we have there? Just one. So 1 pair, 1 line. So that's the line bond structure. That's the Lewis dot structure for hydrogen. That one's not on your worksheet, so let's try one that is. Let's do nitrogen. Find 2 nitrogens.
What's next week? Yeah, but I work Friday.
How many electrons are around each nitrogen?
7.
What is the Roman numeral up there? 5. So 5. I'm going to take 5 green ones. And when you are doing compounds, it doesn't matter where you put them. Okay? When you're doing a single atom, then it goes like this. But when you're doing compounds, it doesn't matter. Put them wherever. So what does the rule say about the nitrogen family? The nitrogen family needs to have 8 around it. So we got to get 8 around them by the time we're done. So what I'm going to do here, Kyle, is I'm going to take 1 here and 1 there. I form a bond between those two.
Wait, did you make the colors?
I did.
We don't know.
Oh, I've got 5 green ones and 5 pink ones to represent the 5 from one and 5 from the other. So how many electrons do I have around this nitrogen right now? 6. How many around this one?
6.
How many do I have to get? 8. So it's not enough. So what I can do is make another pair. Now how many do I have? 7 and 7. Is that enough?
No.
Nope. Let's make another pair. Now we have 8 and 8. And that's what we needed, right?
Yeah.
So when I draw Lewis dot structure, it will look like this. These other two, you can put them wherever you want. You don't have to put them up there. You can put them over here. But you must have them paired. You can't do that. You must have them paired. You should never have an electron hanging out by itself. Unless you know the exceptions to the rules, which you guys don't. That was my disclaimer. Hopefully no one heard
Why is
that.
it actually awesome? Oh.
So they're always paired up. And then I draw my circle just to help me identify, do I really have 8? I really do. Really, really. Three pairs. So how many lines would I draw? 3. That is a triple bond.
So
Yep.
what do we write for the data and observation?
So what you would draw would be the Lewis dot structure first, and then next to it I want you to draw the line bond. I know the lab doesn't ask you to draw the line bond, but I want you to. So do the Lewis dot structure first, then the line bond. Let's see if we can squeeze one more in. Let's do ammonia, which is NH3. So 1 nitrogen, 3 hydrogens.
I need 1 nitrogen.
Nitrogen starts with 5. Again, it doesn't matter where you put them. When you are doing a compound, you can move them wherever. Each hydrogen starts with 1. The rules tell us that we have to get 2 around the hydrogens and 8 around the nitrogen. But what did I forget to do? Always have to do the electronegativity first. And you always do it between each 2 individual ones. So nitrogen is 3.07, hydrogen is 2.20. What's the difference? 0.87. Ionic or covalent? Covalent. Do the same thing between the other 2. 3.07, 2.20. We'll get the same number, right? So it's going to be covalent for all of them. But you always do the difference between each ones individually.
Sir, please call 4509. Karen Spencer, please call 4509.
So then, how do we get 8 around the nitrogen? Form 3 bonds. And how do we get 2 around the hydrogen? There's 2, 2, 2. 8 around the nitrogen. And the Lewis dot structure would look like this. Whichever one there's fewer of will always be in the center. There's only one nitrogen. Three hydrogens. So that's how it looks. And the line bond structure would be this.
I'll put it away.
Sometimes you draw on that lone pair, sometimes you don't. For our purposes in this lab, you do not need to draw on the lone pairs. Very soon, we're going to learn about Vesper theory, and we are going to draw those lone pairs in. No homework this weekend.